Hello everyone. And welcome back once again to another interesting video. In today's video we'll discuss top 20 data science interview questions along with their detailed answers. So if you are ready, let's start today's video. Data science is a multidisciplinary field that involves extracting insights and knowledge from data. It combines expertise in statistics, programming, domain knowledge, and data analysis. When preparing for a data science interview, it's crucial to be well-versed in a variety of topics. Today, I'll provide you with a list of the top 20 data science interview questions and detailed answers. Question 1. What is data science, and how does it differ from traditional statistics? Answer. Data science is an interdisciplinary field that involves the use of various techniques, algorithms, processes, and systems to extract knowledge and insights from structured and unstructured data. It combines elements of statistics, machine learning, computer science, and domain expertise. Unlike traditional statistics, data science often deals with large volumes of data, big data, focuses on predictive modeling, and utilizes a broader range of data sources and techniques. Question 2. What is the CRISP-DM process, and how does it relate to data science projects? Answer. CRISP-DM or Cross-Industry Standard Process for Data Mining is a widely used framework for data mining and data science projects. It consists of 6 phases. 1. Business understanding. 2. Data understanding. 3. Data preparation. 4. Modeling. 5. Evaluation. 6. Deployment. Data scientists use CRISP-DM to guide their projects, starting with understanding the business problem, gathering and exploring data, preparing the data, building models, evaluating their performance, and finally deploying the solutions. Question 3. Explain the concept of overfitting in machine learning. How can it be prevented or mitigated? Answer. Overfitting occurs when a machine learning model performs well on the training data but poorly on unseen data or testing data. It happens when the model captures noise or random fluctuations in the training data instead of general patterns. To prevent or mitigate overfitting, you can use more data to train the model. Simplify the model by reducing its complexity. Regularize the model by adding penalties to the coefficients. Use cross-validation to assess model performance. Ensemble techniques like bagging and boosting can also help reduce overfitting. Question 4. What is feature engineering, and why is it important in data science? Answer. Feature engineering involves creating new features or modifying existing ones to improve the performance of machine learning models. It's crucial because the quality of features can significantly impact a model's accuracy. Good feature engineering can help models discover underlying patterns and relationships in the data. Techniques include one-hot encoding, scaling, imputation, and creating interaction features. Question 5. Can you explain the difference between supervised and unsupervised learning? Answer. Supervised learning involves training a model on labeled data, where the algorithm learns to predict an output based on input features. Examples include regression and classification. Unsupervised learning, on the other hand, deals with unlabeled data and aims to discover patterns, structures, or relationships within the data. Clustering and dimensionality reduction are common tasks in unsupervised learning. Question 6. What is the curse of dimensionality, and how does it affect data science? Answer. The curse of dimensionality refers to the challenges that arise when working with high-dimensional data. As the number of features or dimensions increases, the amount of data required to make accurate predictions also increases exponentially. This can lead to issues like increased computational complexity, overfitting, and difficulty in visualizing data. Dimensionality reduction techniques, such as PCA or principal component analysis, are often used to address this problem. Question 7. Explain the concept of bias-variance trade-off in machine learning. Answer. The bias-variance trade-off is a fundamental concept in machine learning. It refers to the balance between two sources of error. Bias. High bias occurs when a model is too simplistic and cannot capture the underlying patterns in the data. This leads to underfitting. Variance. High variance occurs when a model is too complex and captures noise in the data, leading to overfitting. The goal is to find the right level of complexity that minimizes both bias and variance, resulting in a model that generalizes well to unseen data. Question 8. What is cross-validation, and why is it important in model evaluation? Answer. Cross-validation is a technique used to assess the performance of a machine learning model by partitioning the data into multiple subsets or folds. The model is trained and evaluated multiple times, with each fold serving as both a training and testing set. Cross-validation provides a more robust estimate of a model's performance and helps detect overfitting. Common cross-validation methods include k-fold cross-validation and leave-one-out cross-validation. Question 9. Explain the difference between precision and recall. When would you use one over the other? Answer. Precision and recall are metrics used to evaluate the performance of classification models, especially in cases of imbalanced datasets. Precision measures the accuracy of positive predictions. It is the ratio of true positives to the total number of positive predictions. High precision indicates that when the model predicts a positive outcome, it is likely correct. Recall measures the ability of a model to correctly identify all relevant instances. It is the ratio of true positives to the total number of actual positives. High recall indicates that the model can identify most of the positive instances. The choice between precision and recall depends on the specific problem and its consequences. For example, in a medical diagnosis task, you might prioritize high recall to avoid missing potentially critical cases, even if it means more false positives. Question 10. What are some common distance metrics used in clustering algorithms? Answer. Clustering algorithms group similar data points together. Common distance metrics used in clustering include Euclidean distance, the straight-line distance between 2 points in a multidimensional space. Manhattan distance, the sum of absolute differences between corresponding coordinates of 2 points. Cosine similarity, measures the cosine of the angle between two vectors, often used for text data and high-dimensional data. Jacob similarity, measures the similarity between sets, commonly used for binary data. Question 11. Explain the concept of regularization in linear regression. Answer. Regularization is a technique used in linear regression to prevent overfitting by adding a penalty term to the loss function. Two common forms of regularization are L1 or lasso and L2 or ridge regularization. L1 regularization adds the absolute values of the coefficients as a penalty, leading to sparse models with some coefficients set to 0. It can be used for feature selection. L2 regularization adds the squares of the coefficients as a penalty, discouraging large coefficient values. It helps in reducing model complexity. Regularization helps achieve a balance between fitting the data well and preventing overfitting. Question 12. What is the ROC curve, and how is it used in model evaluation? Answer. The receiver operating characteristic or ROC curve is a graphical representation of a binary classification model's performance across different thresholds for classifying data. It plots the true positive rate or TPR against the false positive rate or FPR at various threshold settings. The area under the ROC curve or AUCROC is a common metric used to compare and evaluate the performance of different models. A model with a higher AUCROC score is considered better at distinguishing between classes. Question 13. What is the p-value in hypothesis testing, and how is it used? Answer. The p-value is a measure of evidence against a null hypothesis in hypothesis testing. In hypothesis testing, you start with a null hypothesis, means typically stating no effect or no difference, and an alternative hypothesis. The p-value represents the probability of observing data as extreme as what was observed, assuming the null hypothesis is true. If the p-value is small, typically below a significance level, for example, 0.05, you reject the null hypothesis, indicating that there is evidence to support the alternative hypothesis. If the p-value is large, you fail to reject the null hypothesis, suggesting that the observed data is consistent with the null hypothesis. Question 14. What is cross-entropy loss, and why is it commonly used in classification problems? Answer. Cross-entropy loss, also known as log loss, is a loss function used in classification problems. It quantifies the dissimilarity between the predicted probabilities and the true class labels. Cross-entropy loss is commonly used because it encourages models to produce well-calibrated probability estimates and is sensitive to differences in class probabilities, making it suitable for imbalanced datasets. Question 15. What are the assumptions of linear regression, and how can you check them? Answer. Linear regression makes several key assumptions. Linearity, the relationship between the independent variables and the dependent variable is linear. Independence of errors, the errors or residuals should be independent of each other. Homoscedasticity, the variance of the residuals should be constant across all levels of the independent variables. Normality of residuals, the residuals should follow a normal distribution. You can check these assumptions using various diagnostic tools, such as residual plots, normal probability plots, and statistical tests like the Shapiro-Wilk test for normality. Question 16. What is the purpose of A/B testing in data science, and how does it work? Answer. A/B testing, also known as split testing, is a method used to compare two versions of a web page, app, or product to determine which one performs better. It's a common practice in data science for making data-driven decisions. Here's how it works. Two versions, A and B, are created, with one containing a change or modification, for example, a new feature, layout, or content. Users are randomly assigned to either Group A or Group B. The performance of each group is measured and compared using relevant metrics, for example, conversion rate, click-through rate. Statistical analysis is used to determine if the difference in performance between the groups is statistically significant. A/B testing helps businesses make data-driven decisions and optimize their products or services. Question 17. What is the difference between bagging and boosting in ensemble learning? Answer. Bagging, bootstrap aggregating, and boosting are ensemble techniques used to improve the performance of machine learning models. Bagging involves training multiple base models independently on different subsets of the training data, with replacement, and then aggregating their predictions. The goal is to reduce variance and improve model stability. Random forest is a popular bagging algorithm. Boosting also combines multiple base models, but it does so sequentially. It assigns higher weight to misclassified data points in each iteration, allowing the model to focus on the most challenging instances. Gradient boosting and AdaBoost are common boosting algorithms. Question 18. What is deep learning, and how does it differ from traditional machine learning? Answer. Deep learning is a subfield of machine learning that focuses on neural networks with multiple layers, deep neural networks. It differs from traditional machine learning in several ways. Depth. Deep learning models have many hidden layers, allowing them to automatically learn hierarchical features from data. Representation learning. Deep learning models can automatically extract relevant features from raw data, reducing the need for extensive feature engineering. Scale. Deep learning models often require large amounts of data and computational resources. Applications. Deep learning has been particularly successful in tasks such as image and speech recognition, natural language processing, and reinforcement learning. Question 19. What is the bias variance decomposition of the mean squared error, MSE? Answer. The mean squared error, MSE, is a common metric used to evaluate regression models. It can be decomposed into three components. Bias (2). This represents the squared difference between the expected value of the model's predictions and the true values. High bias indicates underfitting. Variance. This represents the variability of the model's predictions for different training sets. High variance indicates overfitting. Irreducible error. This is the inherent noise in the data that cannot be reduced. The MSE is the sum of these three components. Balancing bias and variance is essential for building a well-performing regression model. Question 20. Can you explain the concept of a data pipeline in data science? Answer. A data pipeline is a series of data processing steps that transform raw data into a usable format for analysis and modeling. It typically consists of the following stages. Data collection, gathering data from various sources, such as databases, APIs, or external files. Data cleaning, removing or handling missing data, outliers, and inconsistencies. Data transformation, converting data into the desired format, performing feature engineering, and scaling variables. Data modeling, building machine learning models or applying statistical analyses. Model evaluation, assessing model performance using appropriate metrics. Deployment, integrating the model into production systems for real-time predictions. Data pipelines automate and streamline these processes, ensuring that data scientists can work with clean and structured data efficiently. In conclusion, these 20 data science interview questions cover a wide range of topics and concepts that are crucial for anyone preparing for a data science interview. It's important to not only know the answers to these questions but also understand the underlying principles and be able to apply them to real-world problems. Additionally, keep in mind that interviews may vary in difficulty and focus depending on the specific role and company, so it's essential to thoroughly research the company and role you're interviewing for and tailor your preparation accordingly. Good luck with your data science interviews. Remember that the path to success in data science is a dynamic one, and your passion for solving complex problems with data will be your driving force throughout your career. That's all for this video. We will learn more about data science in upcoming videos. So, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.